Okay, well looking here at example 4, it looks like I'm having a fraction out front here on the left that I could distribute inside this bracket. And then I have a fraction out front over here that I can go into that parentheses. What I might start with is this bracket over here on the left is really intriguing to me. And I might kind of do that whole order of operations. Let's clean up that parentheses first, everything that's in there, and then we might consider about bringing in those fractions. So I have 1/2 times 2, make sure I distribute my negative 3x properly, so negative 3x, and right here, plus 12 is equal to, and I'm not going to really do much on that right side, just kind of leave it the way it is. So over here on the left, when I kind of group some terms, a 2 and a 12 is 14, minus 3x is equal to 2/3 times x minus 5. Okay, what I might go ahead and do, it's up to you at this step, depending on how confident you are. We could eliminate the fractions, or if we want to, we could distribute it and then eliminate. What I might try to do actually this time is let's go ahead and try to eliminate those fractions. So I have two denominators. One denominator is a 2 and the other denominator is a 3. So obviously between 2 and 3, the LCD would be 6. Okay, so I'm going to go 6/1 times this left side. And then I'm going to go 6/1 times that right side. Okay. Now from there, what I want to do is just look at what's happening here on the left. You basically have three things being multiplied together. You have this 6/1 times 1/2 times this bracket. 6 times 2/3 times a bracket. And I want to just I'm making more of a point than anything. If you have three things multiplied together, let's say 2 times 3 times 4, do you go 2 times 3 and 2 times 4? No. Remember, you just kind of basically take 2 at a time. You can go 2 times 3 and get 6, and then multiply by 4 to get 24. Or if you wanted to, you can go 3 times 4 and get 12, and then times 2 and get 24. So I want to just make a point is when you have three things multiplied together, you just kind of just start going from left to right. Do the first two together and then come back and get the third one. Okay. So we want to keep that in mind because of what I'm about to do right here. Is when I go 6/1 times 1/2, basically the 2 and the 6 is 3. So what I have is 3 times 14 minus 3x. Over here on the right, 3 into 6 is 2. So 2 times 2 is 4. And then the x minus 5. Okay? And that's what we're working with now. So 3 times 14. Now we can finally distribute among the third product part. So 3 times 14 is 42. Let's see, 3 times 3 is negative 9x. And then 4x minus 20. So let's group those x's together. I'm going to subtract 4x. So they're all together, and then I'll move the 42 over to the right. So 42 minus 42, negative 9 and negative 4 is negative 13. 4 minus 4 goes away, and a negative 20 and negative 42 is a negative 63 or 62. Divide everything through by negative 13, and we get an answer to be x is now going to be positive 62/13. And I know that that's probably as low we're going to go is because remember 13 is a prime number. The only thing that can divide that is just 1 in itself. Okay, so let's go on to our very next example, example 5. We have a radical inside, and what it has is the square root of 4x minus 1, then plus 2 equals 3. Okay, we're going to get over to this note here in just a second, but I'm going to go to that third bullet that we had on the very first page. And the third bullet basically said is anytime you have a radical, you have to isolate it. Right now it's not isolated because you have the radical, but then you have this whole plus 2. So it's really not all by itself. We want to get the radical all by itself before we even go through any step after that. So the first thing ever that you ever want to do whenever you're solving a radical, and this is going to make your life so much easier, is just isolate it. So let's move that 2 over. And by the way, if you're ever in an equation that has more than one radical, then at least isolate one of them. Okay? So 2 minus 2 goes away and you get 1. Now at this step right here is where you all are just perfectly 100% lovely. You guys love to do this. What we're going to do is to get rid of the square root sign is we're actually going to square both sides. It's kind of like how adding and subtracting are opposites of each other. Like up here at the top, we had a +2, so to move it, we did a -2. If you had a number in front of your variable, it was multiplied to that variable, so to get rid of it, we divided. Well, if you have a square root, to get rid of a square root, what we're going to do is square it. And that does is takes the radical away, and you just get whatever's sitting underneath it every single time. And then 1 squared is 1. So just wrapping this up, let's move that constant over. We get 4x to be 2. And then right here, opposite of multiplication is division. So if we divide off that coefficient, we get an overall answer of 1/2. Now, this is where the next part comes in. This is very, very, very important. With the radical, we don't have an option. We have to check our answer. Back up with everything so far up to examples 1 through 4. I had a choice. If I wanted to check it or if I wanted to throw my answer back in and see if I was right, it's up to me, depending on how gross that answer looked like. I wouldn't want to check that 62/13. Doesn't seem like so much fun. But with a radical, you have to check your answer because of one very, very important thing. What's the one thing you can't take a square root of? Negative numbers. That's the whole reason why we have to check our answer. We might want to write yourself a little note right here. The reason why is because you can't take a square root of a negative number. And so you're sitting here going, well, my answer is positive, so why do I have to check? The key is you don't check your answer. You check your answer once you've plugged it back in. I need to plug 1/2 in and make sure that's what's under that radical is still negative. So it doesn't matter about the sign of your answer. No. It's once you plug your answer in, is what's under that radical still positive or does it go negative? Okay, so let's just go in there just real quick. It says the square root of 4 times my x value, so 4 times 1/2 minus 1, and then +2 should equal 3. Well, 1/2 of 4 is 2. And 2 minus 1 is 1, so the square root of 1 plus 2, and the square root of 1 is 1. 1 plus 2 definitely equals 3. So it does check out, but we have to always check with radicals. Okay, so that kind of wraps up our basic introduction refresher back into solving equations. Now we're going to go on to the next part and look at the properties of exponents. Okay, in here with the properties of exponents, hopefully, y'all have all probably been very much exposed to these. So it's just a matter of kind of hopefully just refreshing you like we did with our lines up there, or solving our linear equations. And the very, very first property, if you have x squared and x cubed, what it's basically saying is if you have the same base, notice how I underlined them there, if you have the same base in both cases, then what you do is you keep that common base and you just add your exponents. Okay? But this is just basically saying I have, in general, I've got 2 x's, x times x, and I'm multiplying against 3 more. So obviously, altogether, I've got a total of 5. Simple as that. If you have, on the flip side of that, if you have the common base and you're in fraction this time as opposed to multiplying, if you're dividing, then all we have to do is subtract our exponent. And with here, just remember that if you don't have an exponent written, it's always understood to be 1. Definitely something good to keep in mind. And like I kind of did before, what this is just showing you is up here in the top you have 4, and you have 1 in the bottom. So that 1 just basically cancels off, and that's why you have 3 left over. Okay. Here in part 3, look here. I basically have just one base. It's x. And that x is being squared and then again raised to another power. So if you have one base that's raised to a power and re-raised, what do I do with those 2 powers? I multiply them together. And if you wanted to write this out, it's basically saying x squared, 5 times. There's a lot of these in here. And then each one of these is x times x, x times x. You're getting the drift. So you can see definitely how we're grouping or adding these up quickly to a total of 10. Okay, going on to an example or property number 4, it's what to do with the negative exponent. A lot of people think, oh, a negative exponent makes a negative number. No, definitely not. A negative exponent, when I want to show you guys, really all it does is make a fraction. So one of the easiest things you can do is, you might come over here this way. What all I want to do is anytime I want to make an exponent and I want to make it positive. Right now it's -5. I want it to be a +5. If you ever want to change the sign of your exponent, all you do is take the reciprocal of your base. The base is x, so the reciprocal of x is just 1 over x. As simple as that. Well, if I kind of used property number 3 before, if I want to take this power, I can distribute it inside. That's saying 1 to the 5th over x to the 5th. Well, 1 to any power is 1, and then you have x to the 5th just right there in the bottom. And so you're getting the same answer either way. So just in general, like here, let's go to the second part. I have a negative exponent right here. If I want to make it positive, just take the reciprocal of your base. The reciprocal of 1 over x is just x. As simple as that. Okay? And then, so that's what to do with negative exponents. What to do with fractional exponents? Well, a fractional exponent, just to keep telling yourself, negative exponents just make small numbers. Fractional exponents are talking about a radical. Every time you see an exponent that has a fraction, it has to be referring to a radical, as simple as that. Okay? The bottom number of the radical always tells you the type of root. So in this first part, since the bottom number is a 2, we're looking at the square root. The top number is the exponent. It's what's to do afterwards. Okay, so let's look at this x to the 3/4. The bottom number is a 4, so we're looking at the 4th root. The top number is a 3, so I could do one of two things. I could cube the x first and then take the 4th root, or I could take the 4th root first and then cube it. And this one right here is way more popular. You're going to find that is definitely used more often. Like let's take an example. Let's say I even have, instead of just x, let's say I have 81 to the 3/4. So I have two options. I could take the 4th root of 81, and then after I'm done, when I find that radical, I could cube it. Or I could take the 4th root of 81 cubed, where I have to cube first and then take the 4th root. Well, I'm like, 81 to the 3rd, who wants to do 81 times 81 times 81? Then once you get that huge number, then try to figure out what I have to multiply 4 times to get that. Doesn't seem like so much fun. Let's not try that. Well, let's go back up to this first option, where I take the 4th root of 81 first. So what number can I multiply 4 times and get 81? Well, it's 3. So then I take 3 cubed and get an answer of 27. So there you go. I would have gotten it the other way as well, but it's just something you're like, oh, I don't even have to pull out a calculator for this way. Okay? So basically, going through all these just properties of exponents one more time, it's showing you when to add them, when to subtract them, multiply them, and realizing negative exponents, just take a reciprocal of your base to make them positive. And anytime you have an exponent that's a fraction, all you're referring to is a radical. And there's one last property before we leave this. You might write this in. Property number 6 is saying that anything to the 0 power is always equal to 1. No matter what the base is, as long as it's to the 0 power, it's always going to equal 1. So definitely something that we want to consider whenever we're going through this. Okay, well, let's go down to example 6.